This was scheduled for a 15-minute talk. I actually have about 25 minutes of material, and there's no one scheduled after me. So if it's okay with you, I'm going to run a little bit longer because otherwise I'll be really rushing and skip over some points that I would like to cover. Feel free to leave early if you have to. My name is Paul Lynch. I'm getting a different. Okay, good. So I'm a staff scientist at the Lister Hill Center, the Division of NLM, and I'm technical lead of the LHC FHIR Tools project, which is led by Dr. Clem McDonald. And so he's come up with a lot of the ideas that we've been working on in the project. The tool that I'm going to discuss today is called the Research Data Finder. And it was actually, the current version was developed by Yuri Sedinkin and Hao Ji. So I just want to mention they're very good developers. They both voted that I should be the one to do the presenting. So here I am. So basically the concept of this tool, so I'm going to present the tool, and then we're going to look at some sort of lessons we learned in the development of this tool and problems we ran into. So the basic idea is that it's a tool for researchers who want to pull data of interest out of a FHIR database that contains research study data. The basic steps is the tool sort of walks you through, and I'm going to give a demo in just a second. After connecting to the FHIR server, the researcher sets up some criteria to select a cohort or a group of patients that are of interest. And so they might look at height and weight and blood pressure and other measurements, and to sort of constrain which patients are of interest. So then they can do a search for the patients, and they can see the list of patients that met those criteria, and then they can go back and refine the criteria if needed, if there are too many or too few patients. Then once they're happy with that, they can go to what we call the pull data step, where you can select what kind of FHIR resources you want to pull for the patients, and you can set up different criteria for selecting which observations you want actually for the patients. Once it's pulled, it loads into the browser, and then you can look at it and then download it as a CSV file and to do further analysis like in Excel or R. All right, so let me jump in. So this is our main project website is lhcforms.nlm.nih.gov, and so that has links to all our stuff. Many of those are questionnaire related, so we have the form rendering widget and a form builder. But over here on the right is the link for the Research Data Finder. So, all right. Yeah, so on this first step, you're specifying which FHIR server you want to connect to. Type in the base URL for the FHIR server. And also here, there are some settings you can control. You can sort of tune how many requests there are in a batch, because some FHIR servers might just process the requests in a batch sequentially. So it might actually make things slower to put too many in a batch. For this demo, I've been playing with just one request per, well, if you put in one request per batch, it doesn't use batches, it just sends them. So that works well for this demo. So the next step, when you click next, to go to the next step, you would normally log in, but this is an open FHIR server, so that we won't go to the login step. It does support connecting to Smart on FHIR servers and also OAuth 2. So, okay. On this second step, you're sort of it's asking basically what do you want to do now that you're connected to the FHIR server. So for some FHIR servers, there's a third step where there's some of them will have public data doesn't have the measurements for the patients, but it has the variables, the things that were measured, and you can browse those without actually logging in. Okay, actually, yeah, the login step would happen after you make the selection here. So these two options here are just picking which kind of interface you want to use for defining your cohort. And so I'm going to demo the first one. So here, this is sort of what we call the table-based approach. So you're looking at a table of the research studies, and on this other tab, there's a table of the variables, the things that were measured about the patients in the research studies, so height, weight, other things. For both of these, for defining your cohort, there's a shopping cart metaphor. So you sort of, you can put selected research studies into the cart, and then subsequent queries will be sort of limited to that study or studies, whatever you've picked. And if you don't pick anything, then it just goes across all the studies that you have access to. On the next tab, it's a similar shopping cart metaphor. So again, this is like the list of variables, the things that were measured. So you can scroll through them if you want, and it will keep loading more variables as you go through the list. You can also, which is what I'm going to do, a filter by some keyword that you think the variables that are of interest would have. So I want to do a demo of height and weight variables. So I'm going to filter by weight. And so now it's pulling up variables whose display text have the word weight in them, or that start with the word weight. So I'm going to pick these three, and then I'm also going to pick height variables. I'm going to change the filter to pick up height. So, okay, so I found three. I'm going to pick these two. And so now, if I did nothing else, I just did the search at this point, because it's ANDed here at the top, it would require that patients in the cohort have each one of these 5 variables, which is not really what I want. I want them to have one of the weight variables and one of the height variables, or at least one of them. So what you can do is you can select the ones you want to OR, and you can group those together. Then the grouped ones are always ORed. On the outer level, you can pick AND or OR. And so I'll do the same with the height variables. And then you can also specify value constraints. So probably the researcher doesn't just want to know that they have a weight measurement, but that they're of a certain weight. So I'm going to pick here greater than 150, and I'm going to pick kilograms. This is a list of units that we know are commensurate with the actual measurement that we've pulled. So we could do some more to refine this, because obviously you wouldn't measure a patient's weight in electron mass. But anyway, so you can pick kilogram. And I'm going to leave the value for the weight unspecified. And then I'm going to search for patients. All right, so I found 19, and I'm happy with that. So I'm going to go on to the pool data step. And so here on the pool data step, basically you can select any FHIR resource that for which there's data. And by default, it already gives you a tab, so it gives you a tab for each resource type. By default, it gives you one for the observations, which is sort of the most common case. And it pre-populates the list of codes that you're going to pull with the codes that you specified in the patient criteria. But you're not limited to that. You can get rid of the ones you don't want, and you can pick new ones. And so I want you to notice what's happening here, because I'm going to be talking about this in just a minute when we get to the issues. So I typed SYS because I want to add systolic blood pressure. And so it's giving a unique list of the variables, even though it's looking at the observation table. So, so I'm going to pick these two. So once you've selected the observations that you want to pull, there's also this field that asks you how many you want to pull per patient per test. So you can constrain that. By default, it's just one, so I'm going to go with that. And if it can, it will sort them so that it gives you the most recent one back. That's not always possible depending on the data, but I'll get into that later. So then, so from here you can browse the data that was pulled back, look at the values. So you'll notice that some of these are less than 150 kilograms. That's because, so basically, when we did the search, we were actually just asking, does the patient have any weight value greater than 150 kilograms? So here, the most recent one was less than that. Then if you want, you can click download, and it downloads it as a CSV file, and then you can open it in Excel. So that's as much as I wanted a demo of this system, and then let's get back to the presentation. So lessons learned. So I have 7 of these I'm going to try and cover, and now you can see why 15 minutes was a bit of a challenge. So there's sort of two groups of issues. One's what I'm calling FHIR search implementation issues, and that's both challenges like on the server side and also with this client, which is talking to the server, and then difficulties with the data that we run into in terms of how it's stored in the FHIR server. So the first issue is what I was calling your attention to before when I typed SYS in the field and got back a list of distinct variable names. So the variables are the things that are measured. So like as I've said, the height, weight, blood pressure, and that sort of stuff, which are typically stored in observations that the values are. And so the variables themselves then are the observation codes, right? Those codings that are stored in observation.code. But we want a unique list of those values. So if you're showing the user a list, you don't want them to see 100 instances of the word weight show up. So you might think, well, you could use observation definition for that. And we thought about that, but the servers we've worked with so far don't have that. And I think we've only worked with actually 2 real cases, so it's a limited sample size. Maybe there are more out there that do. And one of them is planning to add observation definition in the future, but they have a long backlog of things they need to work on, so it will be a while. Also, we want to constrain the list to the variables that are just for the patients in the cohort, so not just across all the patients that are in the FHIR server, like all the observation definitions. Because otherwise, if there are 80,000 variables and the patient's cohort or the selected cohort only has 50, then it would be very hard for a user to pick the ones that actually have data. So what we actually do is this. So we send just a query on code text for observation, passing in what the user's typed. So here, the example is if they typed in, where I typed in SYS for systolic, if the user typed in height, we would pass in height for code text. And then you get back, one page of results. Because you're just asking for a page of results that matches height, it could all be the same variable, or it might be just 1 or 2 variables. So then what we do is we follow it up with a second request where we add a code not parameter to exclude the codes that we've seen in the first page of results. And so then we'll either get another page of results back that has new codes, or it will be empty if there just weren't any more. And so you just iterate that process until either there are no more to be found, or you've found enough to show a list to the user. So the problem with this approach is, so here are some actual display text for height variables from one of the systems we connect to. And you can see that sometimes the word height appears at the end of the string, the last word. Sometimes it's in the middle of the string, and sometimes it's at the beginning of the string. So ideally, if you're filtering on height, you want the user to be able to pick from all of these options. As we found out, for some R4 servers, a search on code text will match on word boundaries, so any word that starts with what you've typed. But other R4 servers implemented it to just start at the beginning of the string. Actually, starting in R5, they clarified in the specification that starting at the beginning of the string is what would be the standard behavior. And in the place of the word boundary stuff, what they did is they added a new search parameter, code text advanced, which can handle that case. So it's good for R5, but for R4 servers that just match at the beginning of the string, there isn't really a workaround from the client side to fix that. So we would have to work with the developers of the FHIR server that we're connecting to do something to let us access, to maybe some other custom search parameter, or I don't know what, to be able to access the other variables for that list. So okay, so a second issue, and I am going to get faster on these remaining issues as we go through. There are timeout issues. So I think even if you're just running, I think the default timeout on FHIR is like 60 seconds for a query. But there also can be infrastructure between you and the FHIR server that interferes with things. With one server we were connecting to, there was a like a high-level policy decision made in the organization to just kill all queries if they were still open for longer than 20 seconds. And so that was something that the group that was developing the FHIR service didn't want that, but they weren't able to change it because it was, a decision made up at a higher level. So, so then we have to make sure our queries don't hit that limit, which sometimes we can do. And 20 seconds is a long time for a user to be waiting for a query to come back anyway, which leads to my third issue. So has clauses tend to be slow. And so what we use has clauses is, so if you want to ask the question, which patients have these 3 codes, right? So you're defining your cohort. You want to find the patients that have those 3 codes. Typically, you would use 3 has clauses. You'd query on patient, put in 1 has clause for each code. So, but on our own test server, and this may have less to do with the server we're using than with the database storage that we're using, but it takes 29 seconds to return just for 1 has clause, and then it will time out if we add a second one. And our experience with other FHIR servers is similar. Sometimes we can use 2 has clauses, depends on what the count is of how many observations there are that have each of those codes. But often we can just use 1. So there is a workaround for that on the client side, where you basically you get a count of the observations for each of those codes, and then you sort them. So you start with the smallest one, and you get a page of those results. Then you ask for, okay, of those patients which have the second code, and then of those patients which have the third code. And then if the result of that isn't enough patients, then you go back into the first query and you get a second page, and so you sort of work through. So it can end up being quite a few more queries. It would be nice to be able to just do that with 1. So, all right, so now we're into the difficulties with data section. So one issue we ran into is on one FHIR server we connect to, some of the observations don't have codes, they just have display text. And that was because the group implementing it, their source data didn't have codes, and they didn't have the resources to actually tag it with a proper coding system, a standard code system, and so they just left it blank. Well, if you just leave it blank, then we can't use code not to filter out the codes we've already seen, because there's no code to put there. So if we get a page of observations that's just filled with observations without codes, then our algorithm is stuck at that point. So my suggestion to them, which I don't think they're going to accept, is to just add a local code system, because you can sort of look at some, you can sort of invent your own local code system, and it's fine. It won't be, no one else will understand it, but at least there'll be a code value there, so that someone interacting with your FHIR server can use code not, for instance. Other issues we had is missing display text. So sometimes there is a code in the coding, but there isn't display text, which you can find using a value set validate code operation to find the display, but you can't use code text to do a filter. So then so if it's a small list, you could just download all the possibilities, and then do some client-side filtering after you've found the display text with validate code, which I think is you'd be doing 1 query per coding. If the list is very large, I'm not really sure what would be a good user interface at that point. So, yeah. So my recommendation there would be include display text, not just the code. Missing dates. So because this is research data, they want to make it de-identified so that it's to protect the patients. And but they also will sometimes strip out the dates, so that the observations don't have a date, which means you can't sort by the latest by minus date to get the latest observation. If you actually look at the the variables that they put in, you can sort of see which would be the latest by looking at the display string, but you can't. I mean, there isn't a FHIR query you can do that would pick out to know that quarterly visit 36 was the latest one. Yeah, so probably they'll have to add some extension, that, in a custom search parameter to make that possible. Finally, the last issue that I plan to cover was as sort of a just because of the volume of data they had to process and load, like they have this one FHIR server has like 1 billion observations. They're pulling in for so many research studies, they didn't really have time to do a proper FHIR modeling, at least as their first pass. They're going back to look at how they can improve things now. But the result of that is that things were just sort of, all the pieces of data were just sort of dumped into observations. And again, the variable names sort of give you a clue as to which ones go together, like the dose of the medication and the units. But if those are in separate observations, with there's nothing really to tie them together. They did what they could do with their time constraints, but it makes it less usable than it would be otherwise. All right, so that's all I plan to cover. So here's my contact information and project website. Feel free to contact me. So, are there any questions? Thank you.
Questions?
So, is the idea that others can use this form to put on top of their data on? Is there any thought about it? I'm kind of curious, like if this would be potentially a way for the data management, data sharing plans, like for people to be able to make data accessible and explorable.
So you can connect it to any FHIR server you want. You might if it's yeah. So it depends on what kind of authentication mechanism you have, and yeah. So the idea is basically if you have a FHIR server that you could use this to connect to it, and so it connects either with OAuth 2 or Smart on FHIR. I'm not sure if that answers your question, but yeah, but the basic idea is it helps to help researchers to find the data that they want from the server.
Is it possible to download the data in FHIR resource form, not CSV
Oh,
form?
not CSV. Huh. That's so the researchers we've talked to. It's sort of, yeah, so we could add that. The answer is no at the moment. The researchers we've talked to are generally, like they would do their analysis probably in R, and so that was sort of what we're aiming at.
That makes sense. I was just thinking this would be a great place to find just some example resources to use for development purposes.
Okay.
Thank you.
Yeah.
So this is research data that has been converted into FHIR,
Right.
right? Not clinical data
Right.
that is being used for research purposes.
Right.
So if you were to use clinical data and to do these same queries, do you expect a better set of results? Like less of the missing data, less of the, all,
yes,
you know, all
yeah,
the issues
definitely
that
right. You wouldn't have, yes, that's a good point. So you wouldn't have the date issue unless, well, sometimes the clinical data gets de-identified as well, right? So to make it usable. So actually, the test server we were using started with some de-identified clinical data, and then we did some more, we did some more stuff to de-identify it further. So it's kind of fake data at this point, but it started with that, and so it does have dates, and so that's why for this FHIR server you could actually get the latest values on the observations. So.
Other questions? All right. Well, this was very cool. Thank you very much.
Yeah. Oh, I forgot to mention it is open source, so it's on GitHub. If so you can always download it and install your own version if you want to play with it. So.